Hey everyone, I seem to somehow have become quite obsessed with my Intex salt machine and trying to get it to work properly. So this is a little video about what I've learnt. Got a little mug of coffee to keep me going. And just so you know, I have an Eco 6230. This is what it looks like underneath. I don't think getting it apart would challenge any real hackers. A few screws underneath here. Just pop those out. And then take the two big bolts off of the top to get the electrodes out of the way. Okay, and here's my machine with the lid off. Right here you have a little control board, and this sits inside the top piece. You have to take that off with 4 screws, otherwise it's a real nuisance. That connects to the main brains of the system here. And then behind it you'll see something that you won't have on your salt machine, which is a little something that I've added to mine. Just trying to find out what on earth's going on. Okay, here's the part of my video when you all really lose the will to live. I've spent a happy hour trying to figure out the schematic for at least the part of this machine. And so let me just zoom in on the circuit board, show you where all these bits are. Here's the main power coming in from the rectifier, that's this big guy here. And then there's 2 relays here. They do the switching over to do the cleaning cycle. And this is the main output to the electrode. I'm talking here about the main electrode, which is this one, not the smaller one, the bigger one. So now then, we follow down here. This guy is quite important. This loop here, I'll come to in a sec. I think that's quite an important feature. These 2 yellow capacitors I'm going to talk about, and then this is the op amp. You can see my yellow wire on here, and I'm going to talk to you about that from my schematic. Okay, let's take a little wander around my schematic. So this is where the DC input comes from the rectifier. Goes to this guy, which is a big capacitor to try and smooth things out a bit. And the negative side goes through this loop, which I showed you, and then out to these 2 relays. And they then can switch out the negative side to either of the 2 pins on the electrode, 2 ports on the electrode. So then if you look at the positive side, that goes along here, and then there is another relay here, which you can see on the circuit. And that can either switch the full positive juice from the rectifier, or it can take it through this resistor. And I'm not sure what this is for, either some sort of soft start, or maybe a way of checking that there's no short circuit or something weird going on. Because this resistor really wouldn't last very long at 5 watts with the amount of power that's meant to be going through this system. So anyway, you can switch either the main juice here or a little bit less juice through this resistor into the other side of the relay. So now you can switch positive or negative to either side of the electrode, and that does the flipping over function for the self-cleaning, which of marginal benefit, but that's what it does. So now let's look at this loop. So this loop provides a tiny bit of resistance. Now it's so low I don't have a gear that would measure what that is in ohms. Comes back in 0, because 0 ohms. But anyway, as you shunt a lot of current through it from the electrode, this would generate a teeny weeny bit of voltage, which is what this machine uses to figure out how salty your water is, because the saltier it is, the more juice that will flow through it. So that goes in here, and it goes through these capacitors, which were the yellow ones we saw on the diagram. And this is a little filter network. I'm guessing this takes out some of the ripple, which is either 50 hertz in the UK and Europe, or 60 in the US. So that then goes into the op amp. And so that is a bit easier to show you on a more conventional schematic. So that goes in here. There's this op amp guy here. There's no marking on the chip. I can't figure out what it is, but it makes perfect sense for it to be an op amp. And you can, all dual op amps have exactly the same pin out, this kind of a thing. So it's pretty easy to find out, to figure out what's going on in there. So this is what I've done here. Basically, the first of the 2 op amps here is wired as a voltage follower. Personally, I wouldn't bother with that. I think it's just adds a lot of voltage offset into the system, but nevertheless, that's what they did. So basically, this copies whatever voltage is on here out to its output here. That's its job. Then that goes through a 10k resistor into the positive side of the second op amp, which is this guy over here. And then you can see here, this feedback network here will give a gain of about 50. So if you work that out, it's 47k, 1k, just that's kind of analog electronic stuff. So whatever is going in on here, 50 times that volts will come out here. It's just a way of amplifying it, making it a bit easier for the microprocessor to read it. So now that comes out at point A, which is just there. And if you try and map that, you should be able to see on the circuit board. Point A is where my big yellow wire is. Okay. So that is the voltage out. And then that goes through another filter here, which is this 1k and a resistor and a cap. So the 1k resistor, where the hell is that? Oh, 15, I guess. Yeah, this one here. And then that goes into the micro. Now I've called that point B. Point B has the pink wire on, which I've done a pretty awful job of soldering onto. And point B basically goes into the micro. Just wanted to talk a little bit about my 2 points A and B on here. So point A, that's the point here where the system comes out with a number of volts based on the current that's going through your electrode, and therefore that is what it thinks is the salt level in your system. So this point A goes, in my case, into the Arduino so that I can read it out and get a download of how much salt the thing thinks it's got and how well it's working in general. And at the same time, I can inject some volts in point B, which goes straight into the microprocessor. Now, point B, if I put the right level of voltage, which is like 1.2, 1.5 volts in here, the system thinks, oh, great, I've got just the right amount of salt. I can carry on working away. And this resistor that I left in the circuit, sure enough, a bit of current is going to go backwards and forth across it, but that doesn't seem to bother it at all. So actually it seems to work all right. I can measure the volts that are coming out, saying how much salt there is in the system, at the same time as chuffing volts in and telling it that everything is just fine. Okay, so now armed with all that good stuff, I want to do a bit of measuring to figure out what kind of voltages the system is expecting. So this is basically what I found. If you have a dry electrode, so the thing just hanging in midair, it would kick out about 0.6 of a volt. So that's the offset I was talking about. Anything below that, obviously you're not going to get any sensible reading at all. Then anything below about 0.8 of a volt kicked off a low salt warning, and anything above about 2 volts kicked off a high salt warning. So my idea was, great, I can use my gizmo here, I can download my salt voltages every now and again, check out the system's running all right, if it needs a top up of salt in the pool or electrodes need cleaning. And so I'm thinking, great, job done. Unfortunately, it didn't quite work out that way, because sooner or later, after about 3 or 4 weeks, all I would ever read is the dry electrode 0.64 volts out of my gizmo. So clearly something's not working, and I don't have a clue what. Have I got no salt in my pool? Is the machine actually not kicking out any volts at all? What is going on? So I was scratching my head and I thought, well, the only way to do it is actually put some amps through the system to make sure it's actually working. So I have this set up here. This guy is a load tester that I made out of an old fan heater. You can see this is the row of the heating element at the front, and I've chopped it up into 4 chunks. Right, these are roughly 8 ohms each. I used this first time around to check out an amp I was working on. And now I've fiddled with this a little bit, and I've got all 4 of them tied in parallel, so that's kicking out roughly 2 ohms. I'll measure exactly what that is in a minute. Here's my ammeter in the circuit. Here's my gizmo. So let's fire it up and see what happens. Okay, so here's the system up and running, and let's see what we've got. So here's my load, getting nice and warm as it turns out. Just over 5.5 amps coming through. And I'm reading out about 1.24 volts from my gizmo here. It doesn't have a perfect reading by any means, but it's about 1.24 volts. So basically, it's working, which is quite annoying because it means there's something else going on. Right, so what am I going to try next? So this time I have put my cell back in the circuit and added my meter in there too. And I've calibrated some lovely jam jars here with 1 parts per million of salt, 3, 5, and this baby is straight out of our pool. So I'm going to dunk this bad boy into each one of these in turn and see how many amps I get. Wish me luck. Right, I'm not going to bore you with all three, but here is my 3 parts per million jam jar bubbling away, and that is the recommended amount of salt. Now I'm only getting 0.7 of an amp, which is not very happy. Right, so the results are in, and well, here they are. You can have a read. Basically, it seems to me that the machine wants to deliver something like 5 amps into the pool in order to keep it nice and healthy. And with my electrode, it seems like it's only delivering, well, not very much. You can see I'm not getting enough amps based on 3 parts per million, assuming my measuring is correctly done. But my pool water is also delivering substantially more, and that's because I keep chucking salt in there to try and get this machine to work properly. So basically, what does that all mean? I think it means that my electrodes are screwed. Okay, so just a quick summary. Firstly, I need to say that you may have noticed I haven't done much with this smaller electrode here. Well, since I really haven't honestly made a lot of progress with the big one, I really don't think I've got the will to carry on and mess with that, so I'm going to leave that. Basically, as I said, I've cleaned this guy as much as I can. I can't get enough amps out of it, I don't think, to make the machine work properly. So my conclusion really is that my electrodes are screwed. Now, if you've got one of these machines and you're wondering what to do about it, I would say you can hack it if you like. You might get a few more weeks' life out of it. But chances are, realistically, your electrodes are shot. And guess what? I can't get any more electrodes here in the UK. There's only one place selling them, and they're on back order. And if you look at the price for 2 new electrodes, it is roughly £1 more expensive to buy 2 new electrodes than it is to buy a whole new machine. So chances are, I'm afraid, that your machine is actually going to be landfill. What a shame. Anyway, thanks for watching. Hope you made it this far, and good luck.